generator, observer. Okay. So except pump, there is no requirement of electricity. So still water pump, solution pump, then cooling tower. So in the case of vapor compression system, we required everything required electricity. For condenser pump, if it is water cooled system, we require water pump, then cooling tower fan. Then if it is for air cooled system, then number of fans are there. So we require fan motors. So electricity is very much important there. So evaporator, the refrigerant. So you will see the circuit, evaporator circuit. You could see the evaporator coil, then refrigerant vapor, chilled water, then cooling. It is demand. The chilled water is circulated to the AHU unit or cooling coil. It depends upon the application. If it is central air conditioning plant, it goes to the AHU unit. Chilled water is circulated to the AHU unit. Then in the AHU unit, there is a fan blower. It circulates the air to the space, conditioned space through the duct. Here, refrigerant is the water. The refrigerant, it is water, evaporates at around 4 degrees C under the high vacuum conditions of 754 mm of mercury in the evaporator. When the refrigerant evaporates, the latent heat of vaporization takes the heat from incoming chilled water. This latent heat of vaporization can cool the chilled water, which runs into the heat exchanger tubes in the evaporator by transfer of heat to the refrigerant, that is water. So again, this is the principle of working principle of evaporator in the vapor absorption system. Then observer. In order to keep evaporating, the refrigerant vapor must be discharged from the evaporator and the refrigerant must be supplied. The refrigerant vapor is absorbed in the lithium bromide solution, which is convenient to absorb the refrigerant vapor in the absorber. The heat generated in the absorption process is let out of the system by cooling water continuously. The absorption also maintains the vacuum inside the evaporator. So this is the cycle diagram. So here evaporator and observer. So observer is absorb the heat from the chilled water. Okay. High pressure generator. As lithium bromide solution is diluted, the effect to the absorb the refrigerant vapor reduces. In order to keep absorption process, the diluted lithium bromide solution must be made concentrated lithium bromide. Absorption chiller is provided with the solution concentrating system by the heating media such as steam, hot water, gas, oil, which performs such functions is called generator. It is the heat generator. Concentrated solution flows into the observer and absorbs the refrigerant vapor again. See, the cycle is repeating. So this is the cycle diagram. High pressure generator. So high pressure generator is like a compressor in the vapor compression system. So high pressure generator generate the heat. Then it goes to the concentrated solution. The concentrated solution absorb the heat in the cooling water. Okay. Then other side is the evaporator, where the water is the refrigerant. It cools the water, chill water, 7 degree, that is 12 degree to 7 degree. Other side, observer, it absorbs the heat, 36 degree to 32 degree. It is just like a condenser. Okay. Condenser. In order to carry out above work continuously and to make complete cycle, the following two functions are required. To concentrate and liquefy the evaporator refrigerant vapor, which is generated in the high pressure generator. Number two, to supply the condensed water to the evaporator as a refrigerant. For this function, condenser is installed. So we could see the condenser and evaporator, observer, generator. Lithium-bromide water absorption refrigeration system have a coefficient performance, that is COP, in the range of 0.65 to 0.70 and can provide chill water at 6.7 degree with a cooling water temperature of 30 degrees. System capable of providing chilled water at 3 degrees centigrade are also available. Ammonia-based system operate at above atmospheric pressure and are capable of low temperature operation below 0 degrees C. 2000 machines of capacities in the range of 10 to 1,500 tons are available. Although the initial cost of the absorption system is higher than the vapor compression system, operational cost is much lower if waste heat is used. So here, as I mentioned earlier, motor, working of motors, electrical equipment is less when compared to the vapor compression system. In the vapor compression system, every equipment is required electrical energy, electrical equipment, that is condenser, compressor motor, and condenser water pump, or cooling coil, condenser cooling coil fans, then evaporator system. But for here also evaporator system is required, but other two is we can save the energy. So this is the circuit diagram for the two-stage steam-fired absorbent unit. Okay. We could see the evaporator, steam fired generator, then absorbent type pumps, evaporator spray pump, cooling tower. Here is evaporative cooling. For the evaporative cooling. So this type of system can be used in a hotel industries, because in hotel industries they will use steam boiler or hot water boiler. From there we can use the steam or hot water as a generator. Desirable properties of refrigerant absorbent mixer. It should not undergo crystallization or solidification inside the system. The mixer should be safe, chemically stable, non-corrosive, inexpensive, and should be available easily. The most commonly used refrigerant absorbent pairs in commercial system: water, lithium bromide, then ammonia water. Water, lithium bromide, that is H2O, LiBr. Refrigerant is the water, absorbent is the lithium bromide. So application above 0 degrees C, that is AC plant applications. Ammonia water system, refrigerant is ammonia, absorbent is water, application is the refrigeration applications. It is below the 0 degrees C for cold storage, wherever is required for industrial purpose. So ammonia is a noxious gas, we cannot use for the air conditioning applications. If there is any leakage, then it will be affected the occupant. So it is suitable for the industrial applications. So features of vapor absorption refrigeration system. Lithium bromide water absorption refrigeration system have a coefficient of performance, that is COP, in the range of 0.65 to 0.7, and can provide still water at 6.7 degrees C, a cooling water temperature of 30 degrees C. System capable of providing chilled water at 3 degrees C are also available. Ammonia-based system operate at above atmospheric pressure and are capable of low temperature operations below 0 degrees C. Absorption machines of capacity in the range of 10 to 1,500 tons are available. Although the initial cost of the absorption system is higher than the compression system, operational cost is much lower if waste heat is used. What is the comparison between the vapor compression system and the vapor absorption system? Work operated, heat operated. High COP, low COP, currently maximum of 1.4. Performance very sensitive to evaporated temperature. Performance not very sensitive to evaporated temperature. System COP reduces considerably at part loads. COP does not reduce significantly with load. Liquid at the exit of evaporator may damage compressors. Presence of liquid at evaporator exit is not a serious operation. Here there is no compressor. In vapor compression system, the compressor is the heart of the system. So it is meant for compress the vapor, not for liquid. If there is any liquid enter into the compressor, then the compressor will damage. Performance is sensitive to evaporator superheat. Evaporator superheat is not very important. many moving parts, very few moving parts. So in the case of reciprocating compressors, there is so many moving parts. In the reciprocating compressor, there is a piston, connecting rod, crankcase. Regular maintenance required, very low maintenance required, because here there is no much moving equipments, moving parts. Higher noise and vibration, less noise and vibration. Small systems are compact and larger systems are bulky. Small systems are bulky and larger systems are compact. So economical when electricity is available. Economical where low cost fuels or waste heat is available. So these are all the difference between the two systems. Performance assessment of refrigeration plant. How to assess the performance? This is very important in on energy, that is energy efficiency angle. So the cooling effect produced is quantified as tons of refrigeration. This 1 TR of refrigeration equal to 3024 kilocalories per hour. This heat rejected. So much of heat rejected from the system. Refrigeration is assessed as a TR, that is equal to 2 into Cp into temperature delta T. That is input chill water in and chill water out. Where Q is mass flow rate of the coolant in kg per hour. Cp is coolant specific heat of the specific heat in kilocalorie per kg degree of C. Ti is the inlet temperature of the coolant to the evaporator, that is chiller in degree centigrade. TO is the outlet temperature of the coolant from the evaporator in degree centigrade. The above TR is also called as a chiller tonnage, that is capacity of the particular chiller package. The specific power consumption kilowatt per TR is a useful indicator of the performance of refrigeration system. By measuring refrigeration duty performed in TR and the kilowatt inputs, kilowatt per TR is used as a reference energy performance indicator. The system is efficient or performance is good, then the kW per TR should be less in the order of 0.7, 0.6 and so on. In a centralized chilled water system, apart from the compressor unit, power is also consumed by the chilled water, that is secondary system, coolant pump as well as condenser water for heat rejection to cooling tower. Pump and cooling tower fan in the cooling tower. Effectively, the overall energy consumption would be towards compressor kilowatt, chill water pump kilowatt, condenser water pump kilowatt, cooling tower fan kilowatt for induced post draft towers. The specific power consumption for certain TR output would therefore have to include compressor kilowatt per TR, chilled water pump kilowatt per TR, condenser water pump kilowatt per TR, cooling tower fan kilowatt per TR. The overall kilowatt per TR is the sum of the above. So if you say the specific power consumption of a plant, AC plant, so it includes all the equipment. The theoretical coefficient of performance Carnot, COP Carnot, a standard measure of refrigeration efficiency of an ideal refrigeration system depends on two key system temperatures, namely evaporator temperature, that is TE, and condenser temperature, TC, with the COP being given as COP Carnot equal to TE divided by TC minus TE. This expression also indicates that higher COP Carnot is achieved with higher evaporator temperature and lower condenser temperature. But COP Carnot is only a ratio of temperature and hence does not take into the account of the type of compressor. Hence, the COP normally used in the industry is given by COP equal to cooling effect in kilowatt divided by power input to the compressor in kilowatt. This is the formula for the COP. Performance assessment in a HVAC system. In the field performance assessment, accurate instruments for inlet and outlet chilled water temperature and condenser water temperature measurement are required, preferably with a least count of 0.1 degree C. Flow measurement of chilled water can be made by an ultrasonic flow meter directly or inferred from the pump duty parameters. Adequacy check of the chilled water is needed. Often and most units are designed for a typical 0.68 meter cube per hour per TR, 3 GPM per TR. Chill water flow. Condenser water flow measurement can also be made by a non-contact flow meter directly or inferred from pump duty parameters. Adequacy check of condenser water is also needed often. The most units are designed for a typical 0.91 meter cube per hour per TR. That is 4 GPM per TR. Condenser water flow. That is here. During the performance assessment, we have to take the various data, mainly flow of water, condenser water and chilled water through the flow meters to assess the performance of the system. Evaporative cooling. There are occasions where air conditioning, which stipulates control of humidity up to 50% for human comfort or for process, can be replaced by a much cheaper and less energy intensive evaporative cooling. The concept is very simple and is the same as that used in a cooling tower. Air is brought in close contact with the water to cool it to a temperature close to the wet pulp temperature. The cooling air can be used for comfort or process cooling. The disadvantage is that the air is rich in moisture. Nevertheless, it is an extremely efficient means of cooling at very low cost. Large commercial systems employ cellulose-filled pads over which water is sprayed. The temperature can be controlled by controlling the airflow and the water circulation rate. The possibility of evaporative cooling is especially attractive for comfort cooling in dry regions. This principle is practiced in textile industries for certain process. So this is the there is no condenser, there is no compressor, there is no system at all. Simply a cooling tower. Its open air is forced to the water. That cooling is meant for the industrial application and also for comfort cooling in industries. It's very, very effective and very cheap. Integrated part load value. Although the kilowatt per TR can serve as an initial reference, it should not be taken as an absolute, since this value is derived from 100% of the equipment's capacity level and is based on design conditions that are considered the most critical. These conditions occur maybe, for example, during only 1% of the total time the equipment is in operation throughout the year. Consequently, it is essential to have data that reflects how the equipment operates with partial loads or in conditions that demand less than 100% of its capacity. To overcome this, an average of kilowatt per TR partial loads, that is integrated part load value, have to be formulated. The IPLV is the most appropriate reference, although not considered the best, because it only captures 4 points within the operational cycle. 100%, 75%, 50%, and 25%. Furthermore, it assigns the same weight to each value, and most equipment usually operates at between 50% and 75% of its capacity. This is why it is so important to prepare specific analysis for each case that addresses the 4 points already mentioned, as well as the developing a profile of the heat exchangers operations during the year. It is mainly for the loading pattern. See, throughout the year there is a winter season, then summer season. So accordingly, the system should operate partly based on the requirement, cooling requirement, whether it is industries or the buildings. So the part load operation is very much required. Based on that, there is a PMS, building management system. It sends the online monitoring of operation of the HVAC system. So based on the loading condition in the building, it should automatically control the chill water to the AHU unit, that is evaporator. The chill water, the load is less, then accordingly the chill water flow will be controlled. From there we can save the energy, electrical energy. That means operating hours, operating period for the compressors. Multi-staging for efficiency. Efficient compressor operation requires that the compression ratio be kept low to reduce the discharge pressure and temperature. For low temperature applications involving high compression ratios and for wide temperature requirements, it is preferably due to equipment design limitations and often economical to employ multi-stage reciprocating machines or centrifugal or screw compressors. Multi-staging system are of 2 types, compound and cascade, and are applicable to all types of compressors. The reciprocating or rotary compressors, 2-stage compressors are preferable for low temperatures from 20 to -58 degrees C, and with centrifugal machines for temperature around -40 degrees. So it is telling about the multi-stage compressors operations. So all the compressors, there is a stages, number of 1 stage, 2 stage, and then number of compressor also. Suppose the chiller package capacity is 200 tonnage, then the compressor 2 numbers of 100 TR can be installed. So if the compressor load is reduced, then automatically switch over to lesser capacity. So one compressor switched off. So that is called the multi-staging of the compressors. Take care of the loading pattern. Matching capacity to system load. During part load operations, the evaporator temperature rises and the condenser temperature falls, effectively increasing the COP. But at the same time, deviation from the design operation point and the fact that mechanical losses form a greater proportion of the total power negative the effect of improved COP, resulting in a lower part load efficiency. Therefore, consideration of part load operation is important because most refrigeration applications have varying loads. The load may vary due to variation in the temperature and process. Cooling needs. Matching refrigeration capacity to the load is a difficult exercise, requiring knowledge of compressor performance and variations in the ambient conditions, and a detailed knowledge of cooling loads. This again is linked to the energy efficiency. Whenever the ambient temperature increases, accordingly, the chiller operation can be controlled. Capacity control and energy efficiency. The capacity of compressors is controlled in a number of ways. Capacity control of a reciprocating compressors through cylinder unloading results in incremental step-by-step modulation as against the continuous capacity modulation of centrifugal through van control and screw compressors through sliding valves. Therefore, temperature control requires careful system design. Usually, when using reciprocating compressors in applications with widely varying loads, it is desirable to control the compressors by monitoring the return water or other secondary coolant temperature rather than the temperature of the water leaving the chillers. This prevents excessive on-off cycling or unnecessary loading unloading of the compressors. However, if load fluctuations are not high, the temperature of the water leaving the chiller should be monitored. This has the advantages of preventing operation at very low water temperatures, especially when flow reduces at low loads. The leaving water temperature should be monitored for centrifugal and screw chillers. Energy saving opportunities. So in a HVAC system, how to save the energy? See, cold insulations. Insulate all cold lines vessels using economic insulation thickness to minimize heat gains, and choose appropriate insulation, correct insulations. So we have to do the insulation for equipments, that is chiller, then chill water pipelines. So that is called the insulation, where we can reduce the heat gains, minimize the heat gains. Building envelope. Optimize air conditioning volumes by measures such as use of false ceiling and segregation of critical area for air conditioning by air curtains. Next, building heat loads minimization. Minimize the air conditioning loads by measures such as roof cooling, roof painting, efficient lighting, pre-cooling of fresh air by air-to-air heat exchangers, variable volume air system, optimal thermostatic setting of temperature of air conditioned space, and sun film applications for windows and doors, etc. So this is the how to reduce the heat gains from the outside. Then process heat loads minimization. Minimize process heat loads in terms of TR capacity as well as refrigeration levels, that is temperature required, by way of flow optimization, heat transfer area increase to accept higher temperature coolant, avoiding wastage like heat gains, loss of chilled waters, ideal flows, then frequent cleaning, descaling of all heat exchangers. So heat exchangers in sense in the condenser coils, then chiller coils. The coolant means, it means the chill water temperature at the refrigeration AC plant area. Ensure regular maintenance of all AC plant components as per manufacturer's guidelines. Ensure adequate quantity of chilled water and cooling water flows. Avoid bypass flows by closing walls of ideal equipments. Minimize part load operations by matching loads and plant capacity online. Adopt variable speed drives for varying process load. So here, wherever the cooling load is varying, then accordingly we have to provide the PFT. So here for pumps, secondary pumps, then AH unit, blowers. Make efforts to continuously optimize condensers and evaporator parameters for minimizing specific energy consumption and maximizing the capacity. So with this, I have completed this presentation for the HVAC system. So next we will focus the question papers. So all the friends, they have to go through the previous question papers to 5 years, and you have to continuously practice. So in the HVAC equipment chapter, so every exam there is a minimum of 20 marks, maximum of 25 marks. So 20 marks is sure. So short question will get 15 marks. Then multiple choice question will get 5 marks. Then problems. So we'll get so one exam there is a 20 marks question. Yeah, 10 marks. So this chapter HVAC equipment only carries minimum 15 to 25 marks. So all friends go to practice the question papers. So if you have any clarifications, requested to ask. Sir.
Yes, sir. No, sir. Educating.
So today is only eight friends.
Sir, it was 10, sir. Now only it is 8.
Sir?
It was 10, sir. 10.
Okay.
After your thank you slide, two persons left, sir.
Okay.
Sir, tomorrow class, please be at 9 p.m., sir. Is so particular.
Tomorrow class, I can discuss about the question paper only.
Sir, tomorrow Satyasilan sir is taking class, sir.
Okay, no problem, sir.
He is so particular about the time. He wants the class to start at 9 sharply. You will take the chapter combustion, sir.
Chapter, sir?
Combustion.
Okay. That is a very important, sir.
Yes, sir.
For all 2 and 4, I think.
Yes, sir.
பரந்தாமன் சார், நீங்க ஒரே ஒரு உண்மையை மட்டும் சொல்லிருங்க சார். அவர்கிட்ட 9 o'clock ஷார்ப்பா 5 பேர் வந்துருவாங்க சார். மீதி உள்ளவங்க எல்லாருமே யூடியூப்ல கனெக்ட் ஆயிருவாங்க சார்ன்னு சொல்லிருங்க.
சொல்லிடலாம். அவர்கிட்ட இன்னொன்னு சொன்னேன் நானு, சார் சாப்டர்ல சிலதெல்லாம் இந்த சாப்டர்லாம் ஆல்ரெடி பாதிக்கு முடிச்சது சார் அப்படின்னேன். இல்ல அது பண்ணிட்டு போனாதான் நல்லா இருக்கும்ன்றாரு அவரு. அப்ப அதை ஏற்கனவே பாதி அதை அட்டன் பண்ணவங்க இன்னும் வர்றது இன்னும் கம்மி. அது வேற. அந்த இது செகண்ட் டைம் எடுத்தாலே வர மாட்டாங்க.
3 பேரு அல்லது 4 பேர் ரொம்ப சின்சியராவே இங்கேயே இருப்பாங்க சார், இன்டராக்டிவா. மீதி உள்ளவங்க எல்லாருமே ஆன்லைன்ல பதிவானதுனால அவங்க டிவி இதுல எல்லாம் பாக்கணும்ன்றதுக்காக யூடியூப் டிவில வச்சு பாத்துட்டு இருப்பாங்க சார். உங்க கிளாஸ் சின்சியரா தான் வச்சு
எனக்கு வேற இன்னைக்கு 3ஆம் தேதி வரை எஸ்சி வந்து எடுப்பாருன்றாரு. அவர் வந்து 7 பேர் பார்த்தாருன்னா அவர் என்ன டென்ஷன் ஆவாரு.
நான் வேணா ஆள் கூட்டிட்டு வந்துடுறேன், எஸ்சிக்கு வேணா. கொஞ்சம் கஷ்டம், அத கொஞ்சம் கிளியரா போட்டுருவோம்
சார். கூட்டம் சேருங்க சார்.
இல்ல அதாவது என்ன சேருங்க, அட்மின் ப்ளீஸ் இவங்கள சேருங்க அவங்கள சேருங்க